A solid band of land wraps entirely around a distant sun. This is a ring world, an artificial habitat with the living space of 3 million planets like our own. It began as a dazzling piece of science fiction, but today it stands as one of humanity's most profound engineering thought experiments. By the end of this, you will understand not just if such a thing is possible, but what building it would truly demand of a civilization. We will journey from its origins in story to the brutal physics holding it together, and even confront the strange societies that might live upon its impossible surface. How would you govern a world with no end? What unseen catastrophe could shatter a structure larger than a solar system? The answers redefine our place in the cosmos. What does a project of this scale say about the builders who dare to attempt it? This colossal ring is not a solid shell but a vast, thin ribbon. Think of it as a cosmic racetrack perfectly balanced around its sun. The star sits at the center of the empty hub, beaming light and warmth onto the inner surface of the ring. This is what separates a ring world from a Dyson sphere, a concept we will explore later. A Dyson sphere is a solid or swarm-like enclosure completely surrounding a star to capture all its energy. A ring world is something else entirely. It is an open band, a strip of engineered land forever falling around its sun, using that endless circular motion to create gravity. The physics is familiar. Just as spinning a bucket of water fast enough keeps the water pressed to the bottom, the ring world's rotation pins everything to its inner surface. The star's light shines down the central axis, creating a permanent, sunlit day across the entire landscape. There is no night, only a band of shadow from the giant, distant walls that contain the atmosphere. The idea was thrust into the public imagination by author Larry Niven in his 1970 novel, aptly titled Ringworld. His vision gave us a specific, unforgettable image. In Niven's design, the ring is 1 million miles wide. To grasp that, picture a strip of land so vast you could line up over 100 Earths side by side across its width. Its circumference is an almost incomprehensible 600 million miles. The total living area is not merely that of a planet or even 1,000 planets. It is equivalent to the surface area of 3 million Earths. This single engineered structure contains more usable land than every planet in our galaxy potentially capable of supporting life. It is a declaration so bold it borders on architectural insanity. Yet it presents a perfectly serious answer to a fundamental question. If a civilization outgrows its planetary cradle, where does it go next? The Ringworld proposes an answer. Do not find a new home, build one at a scale that redefines the very meaning of home. That staggering scale creates a problem of its own. How do you keep 3 million Earths worth of people, oceans, and mountains from flying off into space? The answer is not magic, but a simple, violent principle of physics. The Ringworld must spin, and it must spin fast. This rotation is the only thing creating a livable environment on its inner surface. It is not gravity in the planetary sense, the pull of a massive object. It is centrifugal force, the same outward push you feel on a fast merry-go-round. The entire structure is a cosmic carousel, and everything on it is pinned to the floor by its own momentum. To simulate the comfortable one gravity we experience on Earth across a band 1 million miles wide, the Ringworld has to complete a full rotation every 9 days. That speed at that distance is almost serene. The rim would be moving at roughly 770,000 miles per hour. You would not feel this blistering orbital velocity, just the steady, familiar press of your own weight. But this engineered gravity comes with quirks. On a planet, the Coriolis effect is subtle, influencing weather patterns and the rotation of hurricanes. On a ring world, it would be a dominant, inescapable force of daily life. This effect deflects moving objects to the side, a consequence of the ground beneath you moving at different speeds depending on your distance from the star. Fire a rifle bullet north along the ring, and it would curve dramatically east or west. Storms would not spin in familiar cyclones, they would shear into bizarre linear bands. Even pouring water from a height would see the stream twist as it fell. Your own inner ear would constantly sense this subtle tug, a permanent, low-level dizziness written into the physics of your world. This is a far cry from the gentle spin of a space station like the one in 2001, A Space Odyssey. There, the rotation is small and fast, creating obvious visual cues. On the Ringworld, the curve is so vast it appears flat, and the spin is so stately it feels static. The true violence is not in the motion you feel, but in the forces straining to tear the ring apart. Holding that much mass together while it whips around at 750,000 miles per hour requires a material beyond any science we know. The tensile strength, the ability to resist being pulled apart, would need to be akin to the nuclear forces binding an atomic nucleus. We are talking about a building material forged from the fabric of spacetime itself. Without it, the Ringworld would not simply break, it would explode, scattering 1,000,000 Earths worth of rubble across the solar system in an instant. That central sun is far more than a cosmic light bulb. It is the engine of the entire civilization, a reactor of unimaginable power running at no cost and with perfect reliability for billions of years. Every second, our own sun fuses millions of tons of hydrogen, releasing enough energy to power human industry for over 500,000 years. A Ringworld builder does not capture a fraction of this power, they aim to use nearly all of it. The inner surface of the ring basks in perpetual, unfiltered sunlight. There is no atmosphere to scatter the light into a blue sky, no curvature of a planet to bring night. Every point on that 3 million Earth landscape is in permanent high noon. For any life evolved on a rotating planet, this would be a psychological and ecological disaster. You cannot have forests, oceans, or civilizations without a rhythm of day and night. So the builders must engineer the one thing nature provides for free, a sunset. Their solution is an orbital ballet of breathtaking precision, the shadow squares. These are not small panels. They are colossal ribbons of material, each one likely millions of miles long, orbiting the star just inside the Ringworld's plane. They are positioned to cast long, moving shadows across the ring's inner surface, simulating a day-night cycle. As a square passes between the sun and a section of the ring, it brings night to that region. The squares would move in a synchronized sequence, perhaps dozens of them, creating a wave of darkness and light that sweeps around the ring in a predictable 24-hour rhythm. The engineering is mind-bending. These squares must be stable, their orbits perfect for millennia. They must be strong enough to resist solar radiation and the subtle gravitational tugs from the ring itself. A single miscalculation could send one crashing into the ring's surface, an event that would sterilize a continent-sized swath of land. But their purpose goes beyond comfort. Those shadow squares are likely not passive shades. They are almost certainly power collectors, their sun-facing surfaces covered in advanced solar absorption technology. They catch the star's fury, convert it into usable power, and then beam it wirelessly to the ring below. You might see this as vast, silent lasers or focused microwave transmitters painting energy across the landscape, powering cities, industries, and the ring's own stabilizing systems. This transforms the entire structure from a mere habitat into a titanic machine, every sunrise literally plugging the world into the grid. The star is no longer just in the sky, it is in the walls, in the air, in every device. A resident might look up at the band of night sliding overhead and know it is not empty darkness, but a trillion mirrors harvesting the fire of a star, sending the pulse of civilization down to the world below. What kind of society emerges when energy is not just abundant, but absolutely infinite? This infinite energy powers nothing if the ring itself cannot hold together. The true barrier is not engineering, but the very stuff it must be built from. In Larry Niven's novels, the Ringworld is constructed from a material called skrith. This fictional substance is not just strong, it is almost magical, with a tensile strength approaching the forces that bind atomic nuclei together. It is also nearly impervious to damage, capable of shrugging off meteor impacts and even laser fire. Skrith is a placeholder, a name for the one thing we absolutely need but do not have: unobtainium. In the real world, our strongest materials fail catastrophically at this scale. Consider the mightiest substance we can reliably create: carbon nanotubes. These microscopic threads are incredibly strong for their weight, but they are not flawless. They contain tiny defects, and scaling them up to macroscopic cables introduces weaknesses. Even a perfect, theoretical carbon nanotube cable long enough to girdle a star would snap under the centrifugal forces of a spinning ring world. The stress is simply too great. The ring is not merely holding its own mass, it is fighting to fly apart, a tension greater than the gravitational pull of a star. So what could possibly work? Scientists have proposed theoretical substances that sound as fantastical as skrith. One is a continuous pseudo one-dimensional diamond crystal, a perfect, unbroken atomic chain of carbon forged into a sheet. Another candidate is metallic hydrogen, a phase of hydrogen predicted to exist under immense pressure, potentially possessing incredible strength. We have never created stable metallic hydrogen on Earth, and that perfect diamond sheet remains a sketch on a physicist's chalkboard. Their existence is not forbidden by physics, but making them, and then manufacturing them in quantities exceeding the mass of every planet in our solar system combined, is a challenge of an entirely different dimension. This material science gap is the ultimate gatekeeper. It places the Ringworld firmly in the domain of a Type II civilization on the Kardashev scale. This scale measures a civilization's technological advancement by its energy usage. A Type I civilization, which we are not yet, can harness all the energy available on its home planet. A Type II civilization, like the hypothetical builders of a Ringworld, can capture and utilize the total energy output of its star. They would need that mastery not just for power, but for the fundamental restructuring of matter itself. They would not mine asteroids for steel. They would transmute raw hydrogen from the sun's corona into their miracle material, atom by atom, in cosmic factories larger than Jupiter. The Ringworld is not a construction project, it is an alchemical ritual performed on a stellar scale. Without that first impossible ingredient, the rest of the blueprint is just a beautiful dream. But let us assume for a moment that a civilization achieves this god-like feat of material science. They have their skrith. Now they face a problem almost as difficult, keeping their perfect ring from a perfect disaster. But that unbreakable foundation is only the beginning. A world is not just land, it is air, water, and sky. Containing an atmosphere across a band 1 million miles wide is a problem of staggering proportions. On Earth, gravity holds our air tight against the planet's surface. On the Ringworld, the spin provides that gravity, but the edges of the ribbon present a catastrophic leak. Without a barrier, the atmosphere would simply flow over the sides and vanish into the vacuum of space. The solution is as monumental as the ring itself: rim walls. These are not mere fences or mountain ranges. They are continuous cliffs rising from the edges of the land, likely over 1,000 miles high. Picture a vertical barrier so tall it reaches far beyond what we consider the edge of space, a sheer face that would take hours to fall from if you could climb it. Their purpose is simple: to act as a bowl containing the ocean of air so life can breathe. Sunlight would strike the inner face of these walls, creating colossal vertical climates, from frozen tundras at the top where the air thins out, down through alpine zones to the temperate base. They would be their own impossible continents in the sky, utterly uninhabitable but essential to the ring's function, and with the walls comes the weather. This is where the Ringworld's geometry warps nature into something alien. on a planet where the systems are channeled and broken up by mountain ranges, oceans, and the curve of the horizon. On the endless plain of the Ringworld, there is no curve. A storm front once formed could theoretically travel in a straight line for millions of miles. You could have a hurricane the width of a planet that simply does not stop, marching along the ring until it ran into a designed obstacle or dissipated over an equally vast ocean. The Coriolis effect we mentioned earlier would not stop these systems. It would twist them into bizarre, linear spirals. Weather prediction would be the domain of planet-sized supercomputers, modeling fluid dynamics across a surface larger than a galaxy's worth of Earth-like worlds. Passive management would be impossible. The civilization would need active, relentless climate control. They might use orbital mirrors to adjust sunlight intensity over different zones, creating artificial high and low pressure systems to steer the megastorms. They could deploy fleets of aircraft to seed clouds or dissipate them on a continental scale. The oceans themselves would be engineered, their placement and depth calculated to act as thermal batteries, absorbing heat in one region and releasing it in another to maintain a global, and we use that word carefully, temperature equilibrium. A rainy day in one city might be the deliberate result of a climate command center halfway around the ring, opening a valve in the sky. The sky is not a force of nature here, it is a utility as managed as the power grid or the water supply. Living on the Ringworld means accepting that your sunset, your breeze, even your storm, is part of a calculated equation for keeping 3 million Earths alive. This perfect perpetual noon demands an equally perfect interruption. To create the essential rhythm of day and night, the builders would orchestrate a celestial dance with the shadow squares. These are not moons or planets. They are precisely engineered panels, likely ribbons of a light, durable material like graphene or a metamaterial we have yet to invent, orbiting the star just inside the plane of the Ringworld itself. Their sole purpose is to move, one after another, between the sun and the ring's inner surface, casting a band of darkness that sweeps across the landscape. Think of them as a set of giant, silent window blinds on a cosmic scale, each one perhaps 1 million miles long, but only a few thousand miles wide. Their orbits are synchronized with meticulous care so that as one square finishes casting its shadow over a given region, the next one is already moving into position to begin the next night, many hours later. This creates a predictable 24-hour cycle of light and dark that travels like a wave around the entire ring. The engineering behind this is staggering. Each shadow square must be perfectly flat and stable. Even a slight wobble or a tear in its structure could cause the shadow to flicker or distort, creating chaotic light patterns that would devastate ecosystems below. They must also resist the constant barrage of solar radiation and the subtle gravitational nudges from the ring's immense mass. Their positioning is a perpetual ballet, requiring constant micro-adjustments from thrusters or some more exotic form of propulsion to maintain their perfect, silent precession. For the inhabitants, night would be a scheduled event, as reliable as a train timetable but written across the sky. Your city's sunset would occur at exactly the same second every day, announced not by the sun dipping below a horizon, but by a razor-sharp line of darkness marching across the land at thousands of miles per hour. There would be no lingering twilight, just an abrupt transition from full daylight to deep night as the star is eclipsed. This control over the fundamental cycle of life raises profound questions about society. Could different regions petition the climate authorities for a longer day to aid their crops or a longer night to save energy? Would there be a standard ring time, or would time zones become physical locations with communities living in permanent alignment with a particular square schedule? The aesthetics of this artificial world would be unlike anything in nature. A sunset would not be a gradient of warm colors but a stark geometric event. The last sliver of sunlight might vanish behind the perfectly straight edge of the shadow square, plunging the world into a blackness punctuated only by the light of other stars and the faint, glowing band of the ring's opposite side arching overhead. Your concept of beauty, of daily rhythm, of time itself, would be born from engineering, not planetary rotation. The sky is not a mystery here, it is a clock, and its hands are 1,000,000 miles long. The sheer scale of the landscape makes traditional ecology impossible. You are not managing a planet with its single interconnected biosphere. You are curating a museum of every possible environment, stretched across a ribbon wider than 100 Earths. This is not one closed system, but millions of them, each one needing to be perfectly balanced to prevent a cascade of collapse. The first challenge is biodiversity. A functioning biosphere relies on a complex web of producers, consumers, and decomposers. On Earth, this web evolved over billions of years. On the Ringworld, it must be designed, assembled, and installed from scratch. The builders would need a genetic library of staggering completeness, containing the blueprints for every microbe, plant, fungus, and animal required to build forests, grasslands, deserts, and oceans. They are not just planting trees, they are engineering entire food chains, down to the soil bacteria that fix nitrogen and the worms that aerate the earth. One missing link, one overlooked pollinator or a key predator, and an entire continental-sized biome could slowly strangle itself, but containment is the greater nightmare. On Earth, oceans and mountain ranges act as natural barriers, isolating ecosystems and allowing them to develop in unique ways. On the endless plain of the Ringworld, there is no such isolation. A fast-spreading weed or a particularly aggressive insect, once introduced, could travel in a straight line for millions of miles. An invasive species from the simulated African savanna could, over centuries, march unimpeded into the replica of the North American prairie, outcompeting native grasses and unraveling both environments. To prevent this, the ring would need more than just rim walls. It would require internal barriers, vast mountain ranges, or perhaps even force fields, acting as ecological firebreaks between zones. The world would be a patchwork quilt of isolated Edens, each under its own glass dome of managed climate and strict biological quarantine. This leads to a fascinating possibility, the map of Earth. It is almost a certainty that a civilization capable of this construction would include a homage to its home world. A 1,000,000-mile-long stretch of the ring might be dedicated to a perfect, scaled replica of Earth's continents and oceans. You could walk from a painstakingly recreated Amazon rainforest across a miniature Atlantic Ocean and into a perfect copy of the Siberian tundra. This would be less a habitat and more a living archive, a monument to planetary biology maintained with the precision of a museum conservator. Every species, every stream would be placed according to an ancient blueprint, yet even this archive would not be static. Ecosystems are dynamic, they change and evolve. Maintaining the map of Earth in a state of perfect historical stasis would require constant planetary-scale geoengineering. Climate controllers would mimic ice ages and interglacial periods on a schedule. Forest fires might be deliberately set and contained to renew certain landscapes. Extinct species could be periodically resurrected from the genetic library and reintroduced. The environment becomes a performance, a show run by unseen technicians for an audience that may have forgotten what a real, untamed world even feels like. This raises the ultimate question of sustainability. Can any system this vast and intricate truly run itself? On Earth, nature finds a balance through trial and error, extinction and adaptation. On the Ringworld, every process is by design. There is no room for error because an error could sterilize a region the size of Jupiter. The biosphere would not be a self-correcting organism, but a supremely complex machine. It would require godlike oversight, a permanent class of ecologist gods monitoring atmospheric gas ratios, soil health, and species populations across millions of distinct zones. Their tools would be weather control, genetic tweaking, and if necessary, the complete sterilization and reseeding of a failing biome. In such a place, is a wildflower truly wild, or is it just a component in a circuit, blooming because a database says it should? The freedom of an endless plain comes with the most meticulous gardening imaginable. Such meticulous control over life demands a civilization of unimaginable power. This brings us to the true architects, not a species like ours, but a Type 2 civilization on the Kardashev scale. This theoretical framework measures a society not by its politics or art, but by a single, brutal metric: energy consumption. A Type 1 civilization, which humanity is still striving toward, can utilize all the energy that reaches its home planet from its star. A Type 2 civilization, the kind that builds ringworlds, has progressed to a level that seems like magic to us. They do not just use sunlight, they command the star itself, harnessing 100% of its total energy output. Every single joule of power that our sun radiates in all directions would be captured, channeled, and put to work. This is the minimum power requirement for a project of this magnitude. The energy needed is not merely for lighting cities or powering factories. It is for the fundamental act of cosmic restructuring. First, they need material, and a lot of it. The Ringworld's ribbon, if built to the classic specifications, would have a mass roughly equivalent to the planet Jupiter. You do not mine that from asteroids. You dismantle a gas giant. Picture fleets of machines the size of continents descending into Jupiter's storm-racked atmosphere, stripping it of hydrogen and helium, fusing those raw elements into the miracle material scrith in orbital furnaces that glow brighter than moon. The entire planet becomes a quarry consumed over centuries to spin the threads of a new world. The timeline for such an endeavor shatters human comprehension. Even with self-replicating machines, autonomous builders that copy themselves using the raw materials of the solar system, the project would span millennia, perhaps even millions of years. The architects who began it would not live to see its completion. They would have to become something else, perhaps post-biological intelligences living as pure data in the project's central computer, overseeing the slow dance of construction across eons. The logistics are a nightmare of cosmic proportions. You must manage the orbital dynamics of moving planetary masses, ensuring the ring's spin remains perfectly balanced as new segments are added. A single construction error, a segment a fraction of a percent too heavy, would cause the entire ring to wobble, creating catastrophic tidal forces that would rip it apart from the inside. This is project management where the Gantt chart is light years long and the budget is a star. Compared to this, other stellar engineering concepts seem almost modest. A Dyson swarm, for instance, is a vast cloud of individual energy collecting satellites orbiting a star. It captures the same total energy as a ringworld but is built incrementally, piece by piece, with far less terrifying material and stability requirements. Similarly, O'Neill cylinders are smaller, rotating space habitats that could house millions in a comfortable, Earth-like environment. Building thousands of these cylinders would be a monumental task, but it is a task within the realm of a Type 1 civilization's ambition. They are the sensible, modular apartments in space, while the Ringworld is the attempt to build a single, seamless continent that wraps the sky. The choice between these paths speaks to the psychology of the builders. Does a civilization expand through distributed, resilient networks, or does it make a statement of such overwhelming unity and power that its creation becomes a permanent monument in the heavens? The Ringworld is not the logical choice, it is the artistic one, a declaration written in the fabric of a solar system. Scarcity is the engine of every human society we have ever known. On a ringworld, that engine would stall. With a surface area of 3 million Earths, land is not just abundant, it is effectively infinite for any conceivable population. Energy, drawn directly from the star, is limitless. Food could be synthesized or grown in continent-spanning automated farms. When the fundamental drivers of conflict and commerce vanish, what new structures rise in their place? The very concept of a nation-state defined by borders and resources might dissolve. You could walk for 1,000 lifetimes and never reach a frontier, never cross into another's territory. Political power would no longer be about controlling land, but about controlling the systems that make the land livable. This creates a fundamental divide, a new axis of social stratification. On one side are the masses living in the landscape. On the other are the controllers, the technocratic elite who manage the shadow squares, the climate grids, the atmospheric processes, and the foundation's structural integrity. Their power is absolute and invisible. A displeased controller could not send an army. They could simply schedule a permanent eclipse over your city or adjust the weather to bring a century of rain. Their rule would be one of benign, automated necessity, a priesthood of engineers maintaining the God machine. For the general population released from material want, society could fracture into 1,000,000 different experiments. Isolated by vast distances, communities could form around any ideology imaginable. One region, 1,000,000 miles wide, might be a hive mind collective where individuality is considered a quaint disease. Another might be a recreation of ancient Rome, with its citizens knowing full well it is a historical theme park they can leave at any time. A third could be a silent wilderness, home to a handful of hermits who have not seen another human in centuries. Travel across this tapestry would redefine the journey. There are no orbits here, no rocket launches. To travel east along the ring, you simply move in a straight line. But the distances are galactic. A high-speed maglev train moving at several thousand miles per hour would take over 40 years to complete a single loop. This makes physical travel a profound, life-altering commitment, more akin to a generation ship voyage than a commute. Consequently, communication would be everything. A network of lasers or quantum links would flash information at the speed of light, but even that has a delay. A message sent to the exact opposite point on the ring would take over 30 minutes to arrive. The ring would not have a global internet, but a staggered, asynchronous network of local cultures, sharing ideas that are already decades out of context by the time they are received. A unified culture is impossible. Divergence is inevitable. Over millennia, the dialects spoken at one point would evolve into mutually unintelligible languages. The historical memories of different zones would drift, creating their own mythologies about the controllers, or even forgetting the ring is artificial altogether. Some societies might see the arching band of the opposite side of the ring in their sky, a permanent glowing scar of land and light, and worship it as a god or fear it as a damning wall. This leads to the most profound adjustment, the psychology of the sky itself. There is no dome, no horizon. Look up and the land curves up and over you forever. The sun is a fixed, motionless point at the center of a tube of reality. Your entire world is a contained, engineered strip, and you can always see the proof of it arcing overhead. This could breed a crushing sense of claustrophobia, a feeling that the universe is a painted ceiling, no matter how vast. Or it might inspire a unique form of cosmic humility, understanding that you live inside a masterpiece, a thought given physical form. The ultimate question for a Ringworld citizen is not how to survive, but how to find meaning when every material need is met, and the sky is a constant reminder that your world is built, not born. Do you seek truth in art, in virtual realities, in the exploration of inner space, or in the slow, generational pilgrimage to see what lies beyond the next 1,000,000 miles? This immense, curated landscape suggests a purpose grander than mere habitation. Perhaps the Ringworld was never meant to be a permanent home, but the ultimate ark. With its capacity to simulate any environment, it becomes the perfect lifeboat for a galaxy facing catastrophe, or the definitive zoo for a civilization that has met others among the stars. Its 3 million Earths of space could house not just replicas of a homeworld, but living preserves for millions of unique biospheres collected from across the spiral arms. Each zone, sealed behind its own ecological firewall, could maintain alien atmospheres, exotic gravities, and bizarre chemistries impossible to mix. One vast segment might hold a methane sea under a violet sky, home to silicon-based life forms that communicate through shifting crystal structures. Another could be a high-gravity swamp where immense, slow creatures move through a soup of heavy gases. The Ringworld systems would maintain these pockets of otherness with the same precision used for a terrestrial forest, a monument to biological diversity on a cosmic scale. But this role of galactic curator comes with profound ethical weight. Is it preservation or is it imprisonment? The beings within these preserves would not be visitors. They would be specimens, their entire world a carefully managed exhibit, their evolutionary path frozen by the constant, gentle hand of their keepers. A civilization advanced enough to build this might see itself as a guardian, saving life from stellar explosions or planetary collisions. Yet, from the perspective of a captured species, the Ringworld is a gilded cage of unimaginable size, its very perfection a form of extinction, cutting them off from the chaotic, creative forces of a real, evolving universe. This arc would also become the galaxy's greatest library and meeting point. Alongside the biological preserves, there could be archives holding the total knowledge of countless species, stored in formats ranging from crystalline data lattices to living neural networks. The Ring becomes a backup drive for galactic consciousness, a project designed to outlast its builders, perhaps even their empire. It is a message in a bottle, but the bottle is a star system, and the message is life itself. Different sections could be diplomatic enclaves, neutral grounds where emissaries from star clusters with incompatible biologies could meet within tailored environments. The Ringworld transcends being a home. It becomes a legacy, a permanent crossroads and sanctuary built not for a generation but for geologic time. The final, haunting question for such a project is one of loneliness. Did the builders fill it, or did they leave it empty, a gift for a future they would never see? On a world without a horizon, your sense of direction would fundamentally rewrite itself. There are no poles, no equator, no spinning globe to provide a North Star. Instead, your compass points are defined by the Ring's own immutable mechanics. The two primary directions are spinward and anti-spinward. If you face the direction of the Ring's rotation, you are looking spinward, turn around, and you face anti-spinward. These are not just compass points, they are the flow of time and energy. A journey spinward might feel easier with the subtle push of the Coriolis effect at your back, while walking anti-spinward could feel like a constant, gentle resistance. The other axis is vertical. Look up toward the fixed central sun and you are looking inward. Look down at your feet through the foundation and your gaze is pointed outward toward the cold rim and the empty space beyond. Your entire world is a strip and your navigation is locked to its engineered geometry. This rigid orientation dictates the very shape of the land. All water, from the faintest mist to the mightiest ocean, obeys a single, simple rule. It flows from the high rim walls toward the lower central point, which is the band of space directly beneath the sun. Picture the 2,000-mile-high rim walls as the ultimate mountain ranges, catching precipitation from the engineered weather systems. Every raindrop that falls on the outer regions begins a slow, inevitable journey inward. This creates a river system of staggering monotony and scale. Countless smaller streams would merge as they flow inward, converging into titanic rivers that grow wider and deeper with every million miles they traverse. It is plausible, even likely, that these would eventually merge into a single, continuous river, a band of water encircling the star, flowing eternally inward just beneath the sun's path. This world-girdling river might be thousands of miles wide, a placid, slow-moving monster of fresh water, its far shore lost in haze. Crossing it would be a voyage akin to sailing an ocean, yet you would never taste salt. The landforms between these flowing waters would be just as extreme. Mountain ranges would not curve or arc. On an endless plain, they could run in straight lines for distances that dwarf continents. A single, unbroken chain of peaks might stretch for 10 million miles, from one edge of a designated ecological zone to the other, a permanent, snow-capped wall dividing climates. These would be artificial in the most profound sense, not pushed up by tectonic plates, but sculpted by the builders during the ring's formation, perhaps to act as those essential ecological firebreaks or to guide atmospheric currents. Their scale mocks human exploration. A team of climbers could spend generations mapping a single pass, their entire civilization rising and falling before they glimpse the range's end. Mapping this place is an exercise in both infinite detail and hopeless abstraction. A traditional map is impossible as the surface has no edge to frame it. Instead, you would need a continuous scroll, a strip map that extends forever in two directions. Your location would not be a point on a grid, but a set of coordinates. Your distance along the ring's circumference, your distance from the sunward center line, and whether you are spinward or anti-spinward of a designated prime meridian, perhaps the location of the map of Earth. But this mathematical precision collapses under the sheer reality of distance. A region just 1 million miles from a central archive is incomprehensibly remote. Information, even traveling at the speed of light, would take over 5 seconds to make a one-way trip. News, cultural trends, and technological updates would propagate in slow, disjointed waves. A political revolution or a philosophical renaissance could bloom in one zone, thrive for centuries, and fade into myth long before word of it even reached the next administrative sector. This guarantees the existence of the truly lost, not lost in a wilderness, but lost in the sheer sprawl of geography. There could be zones where the maintenance drones failed millennia ago, where the ecology has reverted to a feral, unbalanced state, populated by the descendants of the original inhabitants who have forgotten they live inside a machine. Their sky arch is just the heavens, their sun a fixed god, and the concept of a builder a forgotten creation myth. Other regions might be deliberately isolated, founded by groups who took a maglev train for 100 years to get away from everyone else and then shut down the transit line behind them. On a structure this large, you can achieve perfect solitude not by going to a remote island, but by walking in a straight line for 500 years. The central controllers might monitor the vital systems, the atmosphere and gravity, but they could easily be ignorant of the specific cultures thriving or dying in the endless tapestry under their care. The ultimate paradox of the Ringworld is that its most defining feature, its connected, continuous landscape, is also the very thing that makes a unified understanding of it impossible. You can see the proof of its structure arcing over your head every day, yet you may never know what lies beyond the curve of your own sky. The concept did not emerge from a physics lab, but from the typewriter of a master storyteller. In 1970, author Larry Niven published Ringworld, a novel that would win science fiction's highest honors, the Hugo and Nebula Awards, and permanently etch this megastructure into our collective imagination. Niven's genius was not just in describing an impossible object, but in using it as the ultimate stage for adventure and inquiry. He gave us not just the ring, but the crew sent to explore it, Louis Wu, a 200-year-old human seeking one last great adventure, and speaker to animals, a fierce, cat-like alien from the warrior race known as the Kzinti. Their mission was sponsored by the Puppeteers, a bizarre, two-headed herbivorous species renowned as the galaxy's most cautious and brilliant engineers. The shocking reveal, of course, was that the Puppeteers were not the builders. They had found the Ringworld abandoned, a perfect machine with its gods missing, and they were terrified of whatever could have caused its creators to vanish. Niven populated his creation with dazzling, plausible technologies that answered practical questions. How does a structure with no orbital momentum steer? His answer was the Attitude Jet's colossal thrusters mounted on the rim, firing into space to correct the ring's position around its star. What happens when it is struck by a meteor? A hidden repair system comprised of automated drones and a foundation of superconductive material would swarm to any breach. But beyond the hardware, Niven used his infinite landscape as a laboratory for human and alien societies. Isolated for millennia, the various inhabitants of the Ringworld had devolved into strange, fragmented cultures. Some worshipped their ancestors' advanced technology as magic. Others had forgotten they lived on an artifact at all, their religions built around the arch in the sky. The explorers encountered a city built on luck, where every citizen was a compulsive gambler, and a region where the inhabitants had selectively bred themselves into a form of sexual slavery. The Ringworld itself became the main character, a silent, enigmatic god machine whose very presence asked the deepest questions. What happens to purpose when the builders are gone? Can a civilization that creates heaven simply walk away from it? Niven's work proved that the most compelling feature of a megastructure is not its scale, but the stories of those who live in its shadow, forever trying to understand the mind that conceived it. Niven's abandoned paradise sits at the far end of a spectrum of cosmic engineering. To understand its unique place, we need to compare it to the other giants of speculative construction, starting with its famous cousin, the Dyson sphere. The classic image is a solid, rigid shell completely enclosing a star, a perfect cosmic egg capturing every photon of light. This is the ultimate energy solution for a Type 2 civilization, but it is also a physics nightmare. A solid shell would have no net gravitational pull from the star at its center. The slightest perturbation, a drift in the star's solar flares or the gravity of a passing planet, would cause the entire sphere to crash into its sun. It is an unstable, impossible prison. The practical version is the Dyson swarm. Imagine trillions of individual solar collectors, mirrors, and habitats, each in its own independent orbit around the star, forming a loose, shifting cloud. This swarm captures almost all the star's energy, just like the solid sphere, but it is built piece by piece. We could start building a rudimentary Dyson swarm with technology not far beyond our own, using automated factories on Mercury to churn out solar satellites. It is the sensible, modular, and achievable path to stellar power. The Ringworld is a different kind of compromise. It is not a full enclosure. It is a single, staggering band, a middle ground between a swarm of small parts and a complete sphere. It offers something neither can, a continuous, Earth-like landscape of literally continental proportions. A Dyson swarm gives you limitless energy but confines life to billions of separate island habitats, each a sealed canister in the void. The Ringworld trades some energy efficiency for an open sky and an endless horizon. But that trade comes at the cost of engineering terror. Where a Dyson swarm can tolerate failures, a single broken satellite among trillions, a Ringworld is a monolithic structure. A critical fracture dooms the entire world. It is all your eggs in one basket, a basket spinning at 750,000 miles per hour. For actual living space, humanity's more immediate future likely lies with the orbital habitat, the apartment building of space. Picture the O'Neill cylinder, two giant tubes counter-rotating to simulate gravity on their inner surfaces. They might be 20 miles long and 5 miles wide, containing valleys, towns, and weather under a striped sky of windows and land. A Bernal sphere is similar, a smaller, spherical habitat. These are constructs we can model and test with known materials. You could have thousands of them, a glittering archipelago around Earth or the Sun, each a self-contained world. They are scalable, resilient, and buildable. A fleet of O'Neill cylinders could house billions, but they would feel like what they are, sophisticated containers. You would always know you are inside a machine with a sunline instead of a sun. The Ringworld rejects that containerized life. It is not an archipelago of islands, but the forging of an entire continent into a circle. It seeks to provide not just living space, but the psychological breath of a true world, with unbroken vistas and a sun that feels natural in the sky. It is the difference between living in a comfortable, high-tech skyscraper and living on a planet. The Ringworld aims for the latter experience, but at a price that makes a Dyson swarm look simple and an O'Neill cylinder look like a child's toy. Each structure represents a different answer to the same question. How does life spread beyond its cradle? The swarm chooses distributed, safe efficiency. The cylinder chooses manageable, modular comfort. The Ringworld chooses audacious, terrifying grandeur. It is the least practical, the most dangerous, and by far the most poetic solution imaginable. The perfection of this engineered world is its greatest vulnerability. Every system, from the gravity under your feet to the air in your lungs, depends on flawless, unending maintenance. The first and most terrifying failure is a loss of stability in the ring's rotation. This is not a simple breakdown, it is a death spiral for an entire world. Picture a flaw in the foundation, perhaps a segment built with a microscopic density variation, or the slow accumulation of space dust on one side of the ring over millennia. This creates an imbalance. The ring no longer spins perfectly around its central star, it begins to wobble. This wobble or precession would be catastrophic. As the ring tilts, different sections would drift closer to or farther from the sun. The regions pulled inward would be scorched by increased solar radiation, while those pushed outward would freeze in the deepening cold. But the real horror is the tidal force. The star's gravity would pull on the wobbling ring, trying to correct its path with unimaginable power. This stress would not gently nudge the structure, it would twist it. The Skrith foundation would groan under forces it was never meant to endure. Continents would shudder, mountain ranges would shear apart, and the world-girdling oceans would slosh in tsunamis thousands of miles high, scouring the land clean. To prevent this, the ring must have active stabilization, likely in the form of colossal attitude jets mounted along the rim. These would be engines the size of moons, firing streams of plasma or matter into space to make constant micro-corrections to the ring's spin. Their failure would mean a slow, unstoppable drift into oblivion. Even a stable spin offers no protection from a breach. The floor of your world is a thin membrane holding back the vacuum of space. A puncture is not just a hole, it is a planetary-scale leak. The cause could be anything: a rogue asteroid that slipped past the defense systems, a flaw in the material from a long-ago construction error, or even an internal weapon of unimaginable power. Once the Skrith is torn, the atmosphere obeys simple physics. It rushes out into the void, not as a gentle breeze, but as a hurricane of escaping gas. The leak would create a screaming jet of air that could itself tear the hole wider. Within hours, the atmospheric pressure for thousands of miles around would begin to plummet. The sky would grow thin and cold, clouds would vaporize, anyone in the region would face explosive decompression, their world literally deflating around them. The ring's automated repair systems, like the legendary falling leaves from the stories, would need to swarm the breach almost instantly, spraying sealant or deploying patches. But if the damage is too large or the systems are offline, the leak could become unstoppable, draining the air from an entire segment of the ring over days or weeks, leaving a dead, airless scar under the silent sun. The climate and day-night systems are equally fragile. Those orbiting shadow squares are not fixed in stone, they are dynamic machines in a precise ballet. A collision between two squares or a critical failure in their guidance thrusters would send one tumbling out of alignment. The result is not a temporary blackout. A drifting square could cast a permanent shadow over a 1,000,000-mile-long swath of the ring, plunging it into an eternal, frozen night. Photosynthesis would stop. Temperatures would crash to near absolute zero. Everything in that zone would die, and the corpse of that biome would begin to affect the adjacent regions, potentially triggering a cascade of atmospheric collapse. Alternatively, a square could fall completely, crashing onto the ring's surface. The impact energy would be beyond calculation, a continent-shattering event that would vaporize the foundation and throw enough debris into the ring's atmosphere to blot out the sun everywhere, triggering a global winter that could last for centuries. All of this underscores the most profound psychological reality of life on a ring world. You are not living on a planet with its resilient, self-correcting systems. You are living inside a machine, the most magnificent machine ever conceived. Your survival is not guaranteed by nature's balance, but by the relentless work of unseen systems and perhaps the watchful eyes of the controllers. A single programming error in the climate control network could turn your fertile valley into a desert in a year. A delayed maintenance cycle on the rim wall scrubbers could let your atmosphere slowly poison itself. There is no wilderness to retreat to, no untouched frontier, because every square inch of this infinite landscape is designed and managed. This absolute dependence creates a unique form of existential anxiety. Your sun is fixed in the sky, a constant reminder of both the genius of your creators and the terrifying truth that you are forever a guest in their house, a house with foundations that must never crack. The ultimate nightmare is not an invasion or a plague, but a silent alarm blinking red in a control room that no one has manned for 1,000,000 years. This absolute dependence on a perfect machine leads us to a startling possibility. What if we are not the only ones thinking about such constructions? The search for alien intelligence has long listened for radio signals, but perhaps we should also be staring at the stars, looking for the shadows of their unfinished work. A ring world, or even a partial swarm of its components, would not be invisible. It would announce its presence by stealing light from its sun. This creates a potential technosignature, a detectable mark of advanced engineering on a cosmic scale. Astronomers hunting for exoplanets already use this principle. They watch for the gentle, periodic dip in a star's brightness caused when a planet passes in front of it. A megastructure would create a dip unlike anything in nature. Imagine a star's light curve, not with the symmetrical U-shape of a round planet, but with a bizarre, jagged, and deeply uneven profile. A partially built ring of solar collectors, for instance, might block starlight in irregular, non-repeating patterns. A solid band, like a ring world under construction, could cause a staggering, long-term dimming as it slowly encircles the star. This is not just theory, it is an active frontier in modern astronomy. The most famous candidate is a star called KIC 8462852, often called Tabby's star. Data from the Kepler Space Telescope revealed its light does not behave normally. Instead of clean, periodic dips, it shows wild, unpredictable dimming events. Sometimes its brightness drops by over 20%, far more than any Jupiter-sized planet could cause, and the pattern of these dips is chaotic. The scientific community scrambled for natural explanations. Could it be a swarm of comets, a cloud of disintegrating planetary debris, an oddly shaped dust cloud? Each hypothesis has struggled to fully explain the data. This left the door open, just a crack, for a more extraordinary idea. Could we be witnessing the construction phase of an alien megastructure, a vast array of collectors or even segments of a ring partially blocking the starlight? The key word here is could. No reputable scientist claims to have found aliens at Tabby's star. The overwhelming likelihood is a natural, if bizarre, astrophysical phenomenon, but its very existence proves a profound point. The search for such anomalous light curves is now a legitimate, peer-reviewed branch of astronomy. We are no longer just looking for planets, we are sifting through the light of millions of stars, searching for signatures that defy natural explanation. A completed ring world would present an even more dramatic signal. If positioned perfectly edge-on from our viewpoint, we might see the star's light cut in half by a dark band. If seen from an angle, the star might appear permanently dimmer, as a significant fraction of its light is absorbed by the inner surface of the ring. This transforms the Ringworld from a dazzling piece of fiction into a concrete hypothesis. It gives scientists a specific, if improbable, shape to look for in the data. This search reframes our place in the cosmos. We are not just passive observers of nebulae and galaxies. We have become forensic detectives of cosmic-scale engineering, looking for the smudged fingerprints of a civilization that may have mastered its star. Every strange flicker in the night sky is now a question. Is it a swarm of comets, a new type of stellar physics, or the shadow of a scaffold being built around a sun? The silence in the radio spectrum might not mean we are alone. It might mean the most advanced civilizations do not broadcast, they build. And the evidence is not in a message, but in the missing light of their star, a shadow cast across the galaxy. The silent evidence of a half-built ring shifts our gaze from the stars to the canvas. Long before telescopes hunted for anomalous light curves, artists were already painting the impossible shape of a ring world, giving form to a concept that defies easy visualization. The journey begins on the bookshelf. The original cover art for Larry Niven's novels, like the iconic 1970 painting by Dean Ellis, set a powerful template. It often showed a slice of the ring from a low angle, the vast band of land curving up with impossible steepness to vanish in the haze of atmosphere, a tiny, fixed sun hanging in the center of a tube of sky. This perspective does something brilliant. It sacrifices scientific accuracy for visceral impact. In reality, from the surface, the ring's curve would be so gradual as to appear perfectly flat for hundreds of miles in either direction, the opposite side merely a faint glowing arch high overhead. But the artistic choice to exaggerate the curve, to make it climb like a mountain range into the heavens, instantly communicates the artifact's artificial nature. It tells you in a single glance that you are not on a planet. This visual shorthand has been adopted and adapted by countless fan artists and illustrators, each wrestling with the same problem of scale. Some depict the ring from space, a delicate bracelet around a star, emphasizing its cosmic fragility. Others attempt the dizzying view from the surface, looking up, where the land arches over to become the sky, a city's lights glittering on the underside of a world 10,000 miles away. These images, shared across forums and art sites, form a collective dream of the megastructure, often prioritizing awe over orbital mechanics. This artistic dream found a massive audience through a different medium, video games. The most famous adaptation is the Halo series, though its rings are a different class of structure entirely. The halos are not ring worlds, they are Niven-inspired orbitals, much smaller in scale. Where a true ring world circles a star, a halo orbits a planet. Its width is only 100 miles and its gravity is generated by spin, but its purpose is far darker. It is a weapon of galactic sterilization. Yet the visual language is directly inherited. Bungie's artists mastered the surface level awe. Playing the game, you look up and see the ring curving up and away, a tangible, navigable geography hanging in the sky. It made the concept tactile for millions. You could drive a vehicle across its surface, see the curve of the land, and feel, in a way no book or painting could provide, what it might be like to inhabit such a place. The ring became a character, a setting, and a puzzle all at once. In the tabletop role-playing game Traveler, the Ringworld appears as an adventure location of the highest order, a grandfather-class artifact that offers referees an infinite sandbox for mysteries. These adaptations consistently make the same trade-off. They simplify the staggering physics and logistics to deliver the core experience, the sublime disorientation of living inside a loop. The cumulative effect of these depictions across decades has profoundly shaped public understanding. For many, the Ringworld is not a physics paper. It is that image of the banded arc against the stars, or the memory of staring up at the halo from a green valley. The artistic interpretations have, in a way, democratized the concept. They have captured the emotional truth of the Ringworld, its grandeur, its loneliness, and its sheer, breathtaking improbability. even if they gloss over the details of shadow square orbits and Skrith tensile strength. This is not a failure, it is a translation. Art takes an idea that lives in equations and thought experiments and plants it firmly in the human imagination. It asks not how it works, but how it feels, and in doing so, it transforms a hypothetical megastructure into a shared cultural icon, a symbol of ambition so vast it bends the sky itself into a monument. This legacy of imagery ensures that when we finally do point our telescopes at a star with a strange, repeating dip in its light, we will not just see data. We will see the curve of a world we have already visited in our dreams. That artistic dream of a ring against the stars forces a confrontation with reality. To build it, you must first dismantle a solar system. The ethical weight of such an act is heavier than the ring itself. Does a civilization, no matter how advanced, possess the right to take a stable, natural celestial arrangement and twist it into a monument of its own design? The project begins with planetary demolition. To gather the mass of Jupiter, you would strip apart gas giants, tear moons from their orbits, and grind rocky worlds into raw feedstock. Each of these bodies is a unique record of cosmic history, a 4.5 billion-year diary written in geology and chemistry. Obliterating them erases that history forever. It is the ultimate act of archaeological vandalism, performed on a scale that mocks comprehension. And what of any life that might exist there? We now know that microbial life could thrive in the subsurface oceans of moons like Europa or Enceladus. A Ringworld construction project, in its hungry search for materials, would sterilize these potential cradles of life without a second thought. The ethical framework we apply to a single rainforest or coral reef collapses when the construction site is an entire solar system. This is not terraforming, shaping a dead rock into a living world. It is astroforming, the complete re-engineering of a star system's architecture for a single purpose. It raises a chilling question. Does intelligence by its nature carry a mandate to reshape everything it touches, or does true advancement bring a responsibility to preserve the natural cosmos? The star itself is not spared. Capturing 100% of its output for billions of years is not a passive act. A Dyson swarm or a Ringworld's shadow squares would siphon stellar energy that would normally radiate harmlessly into space. This energy is the star's waste heat, and by using it, the civilization is effectively cooling the star slightly faster than nature intended. On a timescale of billions of years, this might hasten the star's evolution, shortening its stable lifespan by a tiny fraction. For a Type 2 civilization thinking in eons, this is a calculated trade-off, but it is a trade-off nonetheless. They are borrowing from the star's future to power their eternal present. All of this paints the Ringworld as an act of profound cosmic hubris. It is the belief that a species' need for living space and artistic expression outweighs the intrinsic value of a natural system that has evolved in delicate balance for billions of years. It is playing God with real celestial mechanics. From this perspective, the Ringworld is not a triumph, but a tomb, a mausoleum built from the bones of planets to house a civilization that has forgotten how to live within natural limits. Yet there is a compelling counter-argument. Is this not the natural progression of life? A tree does not ask permission to spread its roots through the soil. A beaver does not debate the ethics of damming a stream. Life alters its environment to survive and thrive. Intelligence is simply a more powerful tool for doing so. On Earth, we preserve pockets of wilderness in national parks, but we do not hesitate to build cities, farms, and highways across the landscape. We see this as our right and our necessity. Scaling this impulse to a stellar level is a difference of degree, not of kind. A civilization facing extinction from a dying star or galactic catastrophe has a fundamental right, even a duty, to ensure its survival. Building a Ringworld could be the ultimate act of parental care for 1 trillion future generations, providing a stable, permanent home safe from stellar explosions or ice ages. Furthermore, the creative impulse cannot be ignored. Is a symphony an act of hubris because it rearranges silent air into meaningful patterns? Is a cathedral arrogance because it shapes stone into a prayer? The Ringworld, from this view, is the ultimate work of art, a civilization's masterpiece written across light years. It is a statement that says we were here and we understood the laws of the universe well enough to compose with them. The empty, natural solar system is a blank canvas, and intelligence is the brush. The ethical tension lies in the balance between these two drives: preservation and expression, survival and legacy. Perhaps the mark of a truly mature civilization is not whether it builds a ring world, but why. Is it built from fear and consumption, a desperate hoarding of resources? Or is it built from a place of profound gratitude and responsibility, designed to preserve not just its own people, but also the genetic and cultural records of every life form it has ever encountered, including those from the worlds it consumed? The ring could be an ark, a library, and a garden all at once, a conscious effort to create more wonder than it destroyed. The silent, abandoned ring world of fiction presents the most haunting verdict of all. If the builders are gone, did their ethics fail them? Did the very act of creation contain the seed of their downfall? Or did they simply move on to a higher plane, leaving their magnificent machine as a gift for the next species to rise? The structure itself offers no answer, only the curve of its land against the endless night, a question mark written in script and starlight. The silent, abandoned ring presents a riddle of economics as much as engineering. With material needs erased by endless energy and automated production, what becomes of a society that has outgrown money? The traditional economy, built on scarcity and labor, would dissolve into something unrecognizable. You would not buy food from a solar-powered synthesizer that can create any meal on demand. You would not pay rent on land so abundant it has no meaningful value. The very concept of ownership might fade, replaced by access and curation. In such a world, the old currencies of gold and digital cash become meaningless. New forms of value would emerge from the only things left that are not infinite: time, attention, and unique creation. One potential currency is the energy credit, but not as a token for basic sustenance. With stellar power flooding the system, energy itself is free. Instead, an energy credit might represent a right to extraordinary consumption, a license to power a personal continent-sized art project, or to accelerate a private virtual reality universe for a century. It would be a measure of ambition, not survival. More likely, the true economies would be social and creative. Reputation could become a quantifiable, vital asset. You're standing in a network, the wisdom of your philosophical contributions, the beauty of the landscapes you design, or the compelling experiences you craft in virtual realms. These could be your capital. In a world where anyone can have anything material, the only true luxury is meaning, and meaning is forged through creativity and recognition. Work itself would be utterly redefined. The grueling labor for food, shelter, and security vanishes. Purpose must be found, not assigned. For many, work becomes play, a chosen pursuit of mastery or expression. New industries would bloom from this limitless leisure. Experienced crafters would design immersive historical reenactments or alien sensory journeys, selling not a product but a memory. Ecological artists would shape entire biomass as living sculptures, competing for the privilege to redesign a 1,000,000-square-mile valley for the aesthetic pleasure of its inhabitants. Virtual reality architects would build entire cosmologies of thought and sensation, their creations becoming the new frontiers for exploration. Perhaps the most critical profession would be maintenance philosopher, a fusion of engineer, ecologist, and ethicist. Their job is not to turn a wrench, but to contemplate the deep principles of the ring systems, to model the long-term ethical implications of a climate adjustment, or to design rituals and stories that help the population understand and respect the God machine they live within. Their work ensures the society remembers its fragility, preventing the amnesia that could lead to catastrophe. This liberation carries a profound risk: the descent into stagnant hedonism. With every need met, a population could fragment into isolated pleasure seekers, lost in endless cycles of tailored stimulation, their culture growing shallow and directionless. The history of any society with a leisure class shows this danger, yet the opposite potential burns even brighter: a cultural renaissance of unimaginable scale. Freed from the daily grind, millions of minds could turn to pure mathematics, cosmological art, or the exploration of consciousness itself. The ring could become a university the size of a solar system, with each zone dedicated to a different school of thought or artistic movement, all cross-pollinating over the slow centuries. The great project of society would no longer be production but understanding, the collective endeavor to answer the deepest questions of existence, beauty, and purpose. The ultimate economic output of the Ringworld would not be goods, but legacies, ideas, and states of being so refined they become the new wealth of a civilization that has conquered necessity and chosen to build meaning from the raw materials of eternity. This artistic grandeur collides with a fundamental law of physics, a flaw so critical it nearly shattered the entire concept. In the years after Larry Niven's novel won its awards, a chorus of voices rose from readers who are also physicists and engineers. They delivered a devastating verdict: the Ringworld is unstable. The problem is not the material but the geometry. A simple ring orbiting a star is not like a planet in a neat gravitational embrace. It is a rigid band with no inherent gyroscopic stability. Picture a bicycle wheel spinning perfectly upright. Now, imagine giving that wheel the slightest nudge to one side. It will not correct itself. It will wobble more and more violently until it crashes. This is precisely what would happen to Niven's creation. Any perturbation, a meteor impact, the gravitational pull of a passing star, even the uneven accumulation of dust on one side would cause the ring to tilt. Once that tilt begins, the central star's gravity would act on it, not to fix it, but to make the wobble worse. The ring would seesaw wildly, its inner surface scraping against the edges of the sun's corona, scorching continents and freezing oceans in a chaotic, world-ending dance. Niven, to his immense credit, embraced this criticism. He did not ignore it, he wrote it into his sequels. The instability became a central plot point, a ticking clock forcing his characters to find a solution within the story itself. They discovered that the legendary engineers had installed colossal thrusters, attitude jets mounted on the rim, which fired automatically to correct the ring's position. This was more than a clever retcon. It was a dialogue between fiction and real science, each making the other stronger. This rigorous scrutiny defines a special branch of storytelling: hard science fiction. Here, the fantastical setting is not a backdrop, but a character bound by the known laws of physics. The goal is not to break the rules, but to explore their outermost limits. Authors become thought experimenters, using these immense constructs as tools to ask, what would it truly take? This pursuit has spawned designs more modest and perhaps more plausible than the original Ringworld. Consider the Bishop Ring, proposed by scientist Forrest Bishop. This is a scaled-down cousin. It is much narrower, perhaps only 1,000 miles across, and rotates to create gravity along its inner rim. Crucially, it is not placed around a star. Instead, it orbits a planet or sits at a stable Lagrange point in a solar system, using mirrors to reflect sunlight into its interior. It abandons the dream of a continent-wide landscape for something more manageable, a habitat the size of a small country but stretched into a loop, offering an endless valley under an artificial sky. It trades staggering scale for engineering that, while still far beyond us, does not require magic materials. Then there is the mind-bending topopolis, sometimes called a cosmic spaghetti. Imagine not a single ring, but a tube of habitable space millions of miles in diameter. twisted into a giant, looping knot that wraps around a star not once but countless times. The living surface is the inside of this noodle, which forms a complex, three-dimensional labyrinth around the star. A traveler could journey forever along its length without ever doubling back, navigating a maze of astronomical proportions. Its stability comes from its complex topology. The way its twists and turns might interact with gravitational forces differently than a simple band. These are not blueprints for construction. They are stress tests for our imagination and our mathematics. Hard science fiction uses them to probe questions with real weight. How does a society manage closed ecological systems over geologic time? What social structures emerge when your world has no hidden corners? What happens to the human psyche under an artificial sky that never changes, or one that is a permanent arch of land? By grounding the dream in physics, these stories force a critical shift. We stop asking, wouldn't it be cool, and start asking, what would it cost, what would break first? The answer is never simple, because the most fragile component might not be the Skrith foundation or the orbital mechanics. It might be the civilization that builds it, forever balancing on the knife edge between godlike power and absolute dependency. The Ringworld and its descendants stand as the ultimate classroom, where the lesson is not about building a bigger house, but about understanding the universe well enough to know if you should. The path from our scattered cities to a ring encircling a sun is not a single leap, but a ladder of escalating ambition. Our first real step off the planetary cradle is not a megastructure, but a habitat. Picture the O'Neill cylinder, a concept from the 1970s that remains our most plausible blueprint for space living. These are not cramped space stations, but spacious valleys contained within rotating tubes, perhaps 20 miles long and 5 miles wide. Sunlight pours in through vast windows reflected by mirrors, creating a cycle of day and night on farmlands and towns nestled along the inner curve. We would build not one, but hundreds, then thousands of them. They become our archipelago in the void, orbiting Earth or later the Sun itself, housing millions in environments far more Earth-like than the surface of Mars or the Moon. This is a technology we can model with known materials, a challenge of engineering, not of miraculous physics. Mastering this gives us something priceless, a generation born and raised in space for whom the void is not a frontier but a home. Their perspective, their very physiology, would begin to diverge from earthbound humanity, shaping a culture intrinsically linked to living inside crafted worlds. With this foundation of space-born communities, our energy appetite would skyrocket. Powering a growing orbital civilization with solar panels alone is inefficient. So we look sunward and we begin to build a cloud. This is the Dyson swarm, the logical next industrial phase. We would launch self-replicating factories to Mercury, a world rich in metals and bathed in intense solar energy. These factories would build vast, lightweight solar collectors, each one a mile wide, and launch them into independent orbits around the Sun. One becomes 10, 10 becomes a million. Slowly, we weave a loose, shifting net around our star, capturing a growing percentage of its total energy output. This is not a solid shell, but a distributed, resilient power grid on a stellar scale. The swarm provides the unimaginable energy budget required for the next phase, cosmic mining on a planetary scale. Fueled by the swarm's endless power, our machines grow more ambitious. We send them to the asteroid belt, not with pickaxes, but with molecular disassemblers. They crack apart asteroids, sorting their raw elements: iron, nickel, silicon, carbon. These become the feedstock for more factories, which build more miners. The operation snowballs. Once the asteroids are consumed, the gaze of our automated industry turns inward to the rocky, metal-rich inner planets. Mars and Venus, and perhaps even Mercury's stripped husk, are systematically deconstructed. Their material is flung into precise orbits, sorted into immense stockpiles of refined matter. This process would take millennia, a slow-motion consumption of worlds, but to a civilization thinking in geologic time, it is simply resource gathering. The final act is assembly. In a stable orbit around the Sun, we begin spinning the first segment. It might be a mere ribbon, 1,000 miles wide and 1,000,000 miles long, a proof of concept built from asteroid iron. Its rotation creates gravity along its inner edge. We seal it, give it an atmosphere, and plant the first seeds of an engineered biosphere. It is a bishop ring, but on a grander scale. Then we build another segment, 100 times larger, then another. Each new arc leverages the energy of the Dyson swarm and the material from a disassembled world. The segments are spun up, stabilized, and painstakingly connected, their edges welded with forces that can mend continental plates. Over centuries, the disconnected arcs become a necklace and then a continuous band. The Ringworld does not appear in a flash of glory. It accretes like a pearl forming around a grain of sand, except the grain is a star and the pearl is a world. This roadmap reframes the Ringworld completely. It is not a project you start, it is a destination you grow into, the end result of 10,000 years of space-based industry, a civilization evolving from planet bound to star managing. The goal ceases to be the ring itself and becomes the journey, the relentless generational project of learning to use a solar system as our workshop. In this light, the Ringworld is not an endpoint but a milestone, a testament that a species finally learned to think and build on the same scale as the universe itself. The basic ring is a starting point, a canvas for even wilder architectural dreams. Each twist on the formula asks a new question about how we might live among the stars. The simplest step down in scale is the Stanford Torus, a design from a real NASA study in the 1970s. Picture a bicycle tire a mile across, rotating in space to create gravity along its inner rim. The tire itself is the habitat, a valley contained within a tube, with sunlight reflected into its central void by a giant mirror. It feels less like a world and more like a spacious, circular space station, a single town wrapped into a loop. This is not a megastructure, it is a neighborhood in orbit, a plausible first home for a few thousand people beyond Earth. It trades the infinite planes of a Ringworld for a cozy, comprehensible community where you could literally see your home on the far side of the circle. But what if you wanted to keep the vast scale but solve the stability problem? One idea is to add spokes. A Ringworld with spokes would look like a colossal wagon wheel, with a habitable band connected by rigid or tethered pathways to a central hub station surrounding the star. These spokes would not be for decoration, they would be structural. They could anchor the ring, physically preventing the catastrophic wobble that dooms a free floating band. More intriguingly, they could become the ultimate transportation system. Instead of traveling millions of miles along the ring's surface, you could take an elevator up a spoke to the hub. From that central point, you could transfer to another elevator descending a different spoke, delivering you to a destination on the opposite side of the ring in a fraction of the time. The spokes become cosmic subway lines, turning a journey of lifetimes into a commute. For a truly disorienting experience, consider the Mobius Ringworld. Take the classic band, give it a single half twist and connect the ends. The result is a surface with only one side. You could start a journey on what feels like the outer edge, walk the entire loop, and find yourself on the inner surface without ever crossing a boundary. Day and night cycles here would be a surreal puzzle. Would the shadow squares orbit on one side of the twist, or would you need a more complex system of lights? The living conditions would be a study in psychological adaptation, as the very ground beneath you seems to invert its relationship to the sun over the course of your travels. This is a habitat built not just for living, but for perpetual, mind-bending exploration. Stability returns as the focus with a dual ring world. Imagine two identical rings, stacked one inside the other like grooves on a record, spinning in opposite directions around the same star. This counter-rotation could neutralize the dangerous gyroscopic forces, creating a system that is dynamically balanced and far more resistant to tilting. The engineering is twice as insane, but the payoff is a safer structure. The space between the rings could become a fascinating frontier, a zero-gravity zone bathed in the reflected light of two inner surfaces, perfect for orbital docks or cities that float between the worlds. The most dramatic variation changes the power source entirely. A ring world around a black hole abandons the friendly light of a star for the violent glow of a dying sun. The ring would orbit at a safe distance from the event horizon, but it would draw its energy from the black hole's accretion disk, the superheated whirlpool of matter spiraling into oblivion. This disk could shine with the brightness of 1,000 stars, providing immense power, but the light would be a harsh, directional beam like a cosmic spotlight rather than a sun at the center. The habitat would need to be carefully oriented to catch this energy, creating a permanent, glaring day on one side and a deep, cold night on the other. Life here would exist in the glare of a cosmic furnace, a civilization powered not by creation, but by the most destructive force in the universe. Each of these designs is more than a science fiction doodle. They are stress tests for the core concept, proving that the ring-shaped habitat is a template for endless imagination. They ask what we value most. Is it stability or the freedom of an open plain? Is it efficient travel or the mystery of an endless journey? Is our energy drawn from life-giving light or from the edge of oblivion? The answers are not in our engineering manuals, but in the stories we tell about who we might become and what kind of sky we would choose to build for our children. Your sky is a permanent glowing scar. Directly overhead, the land from the opposite side of the ring curves up and away, a band of sunlit terrain and distant seas arching across the heavens until it fades into the atmospheric haze 100,000 miles distant. At the precise center of this vast, hollow tube of reality hangs your sun, an unwavering point of light that never rises, never sets, and never moves. There is no dome, no horizon in the traditional sense. Your entire world is a contained strip, and the proof of its artificiality is painted across the sky every single moment of your life. This view would rewrite human perception from the ground up. On Earth, the horizon gives us a subconscious sense of place and scale, a comforting boundary. Here, your eyes are drawn upward along that impossible arch, a constant, silent reminder that you are inside something. This could induce a profound form of landmark vertigo, a disorientation not from height, but from infinite lateral exposure. You are not at the bottom of a bowl looking up. You are on the inside wall of a cylinder looking across. The sheer scale might make you feel simultaneously exposed and trapped, a tiny speck on a surface so vast it becomes the sky itself. In such an environment, art could never depict a sunset over a curved horizon. Instead, masterpieces might capture the stark, geometric beauty of the Terminator line, the razor edge of the shadow square as it slices across the arch, plunging the world from brilliant day to absolute night in minutes. Poetry would speak of the fixed sun and the eternal arch, not the wandering moon. Religion would face a fundamental crisis of cosmology. A culture that knows its world is built might see the controllers as literal gods, or might reject deity altogether in favor of a grand, mechanistic philosophy. Some might worship the arch itself as the body of a world serpent, or see the unmoving sun as the all-seeing eye of a silent, judgmental creator. The very concept of heaven would be complicated, for what is above you is not an infinite void, but more land, more cities, more of the same engineered reality. This could breed a deep, collective claustrophobia, a feeling that the universe is a painted ceiling no matter how far you travel. Yet, for others, this knowledge could inspire a unique, terrifying form of cosmic dominion. We are not subjects of a random universe. We are the heirs of gods who bent physics to their will. The arch is not a cage, it is a crown, the ultimate monument to the power of mind over matter. Philosophy here would grapple with questions of purpose that we can barely articulate. If your world is built, then your life is by extension part of that design. Are you a citizen or a component? Is free will an illusion in a machine where even the weather is scheduled? This could lead to radical schools of thought, from absolute existential nihilism, believing all action is meaningless within the grand design, to hyper-rationalism, where the goal of life is to understand and perhaps join the ranks of the system's maintainers. And beneath it all, in the quiet moments, there might surface a profound, aching longing. On a clear night when the shadow square brings darkness, you could look out through the plane of the ring and see the actual stars. Not the fuzzy band of the Milky Way as we know it, but a thin, precise stripe of black velvet dotted with true, distant suns, framed above and below by the faint, glowing edges of the ring's lit surfaces. In that narrow window, you might see a faint, wandering dot, a planet from the original solar system. You would hear legends of a different sky, a blue dome by day and a deep, star-filled black by night, with a silver moon that waxed and waned on its own mysterious schedule. That longing for a natural celestial dance, for a cosmos that feels infinite and unconquered, might be the deepest nostalgia of all, a homesickness for a kind of sky your species may have never actually seen, but somehow knows it has lost. That profound longing for a natural sky hints at the ultimate mystery, the motive of the builders themselves. Why would any civilization undertake such a staggering act? Survival is the most practical and compelling answer. A ring world is the ultimate lifeboat. It places an entire species inside a stable, controlled environment, safe from the cosmic dangers that plague planetary life. A nearby supernova, a gamma-ray burst, or the slow death of its own star would spell doom for a planet-bound culture. But a civilization living on a mobile ring could, in theory, use its colossal attitude jets to gently maneuver its entire world out of harm's way, migrating to a safer orbit or even a different star system over millennia. It is a fortress against a hostile universe, guaranteeing continuity for billions of years. The scale provides more than safety. It provides room, endless room for a population to grow without ever straining its resources. It solves the problem of expansion permanently, yet pure survival does not demand such artistry. A Dyson swarm provides the same energy and could house just as many people in countless smaller habitats. The Ringworld's unique offering is not just space, but a specific kind of space, a continuous, open, world-like experience. This points to a second, deeper motive, power, but not in the crude sense of domination. It is the power of total mastery, the demonstration that a species has graduated from being a subject of physics to becoming its author. To build a ring world is to announce that you have moved beyond using tools to using reality itself as a medium. You are not harnessing a star, you are wearing it as a piece of jewelry. It is a statement of sovereignty so absolute it becomes a form of cosmic performance art. This leads us to the possibility of legacy. The ring world could be a library, an archive built to outlast its creators. Its 3 million Earths could be curated galleries of galactic biology and knowledge, a message to the future written not on stone tablets, but in living ecosystems and encoded into the structure of its foundation. It is a civilization shouting into the darkness of time, we existed, and this is what we understood. It is a bid for immortality through architecture, a monument meant to endure long after the species that built it has evolved into something unrecognizable or vanished entirely. Ultimately, the drive to build a ring world may be the same impulse that led humans to erect pyramids, to carve cathedrals that scrape the sky, and to launch fragile stations into the void. It is not merely need, but the need to make meaning. The pyramid was a stairway to the gods for a pharaoh's soul. The cathedral was a forest of stone meant to inspire awe and devotion. The space station is a promise to the future. Each is an expression of a culture's highest technical ability married to its deepest spiritual or exploratory yearnings. The Ringworld is the culmination of that lineage, a work where the engineering is the art. Its beauty is in its function, its grandeur is its scale, and its purpose is the act of creation itself. So, is this the pinnacle of a healthy, expansive civilization, or the ultimate symptom of decadence? A healthy civilization looks to the stars and sees a challenge to grow, to learn, to secure its future in a grand and sustainable way. Building a ringworld could be the ultimate act of nurturing, providing an eternal, safe home for quintillions of lives and preserving the beauty of the cosmos within it. Yet, a decadent civilization might see the same stars and feel only the need to consume, to rearrange everything into a monument to its own glory, sterilizing natural worlds in an act of cosmic vanity. The difference lies in the heart of the builders. Is the ring born from a place of gratitude and stewardship, or from arrogance and boredom? The silent, completed ring world, especially an abandoned one, offers no easy answer. It simply hangs in the void, a perfect loop of possibility, reflecting back at us our own ambitions and our deepest fears about what we might become when there are no limits left to test. The arch in the sky is more than a marvel of engineering, it is a mirror. This journey began on the pages of a novel, a dazzling fiction that refused to stay confined to the imagination. It pulled us into a vortex of real physics, demanding answers to impossible questions. We grappled with the need for materials stronger than the forces binding atoms, for energy systems that could tame a star, and for a stability so perfect a single wobble would mean oblivion. We wandered its endless plains, only to find that its greatest challenge was not holding the ring together, but sustaining a society within it, where ecology becomes a curated performance and meaning must be manufactured from infinite leisure. The ringworld stands as a paradox, a symbol of our species' most breathtaking ambition, and a stark warning about the cost of cosmic hubris. It represents the pinnacle of a civilization's power, the ability to restructure a solar system into a monument, yet it also whispers of a profound loneliness, the potential for a creation so perfect it becomes a gilded cage. We may never spin a band of skrith around a sun. The laws of physics and the sheer audacity required may forever keep it in the realm of thought experiments. But that is precisely where its true value lies, the struggle to understand how we could build it, to confront each staggering problem from material science to social design, forces our minds to expand. It pushes the boundaries of our physics, our engineering, and our philosophy. It asks us not just what we can build, but what we should build and for what purpose. So keep looking up at the stars. They are not just points of light, they are the first canvases for these colossal dreams. What megastructure captures your imagination? Share your vision in the comments below, and if you want to explore more frontiers of future technology and lifestyle, subscribe to stay with us on this journey. The universe is vast, and our ideas for shaping it have only just begun.